Hello, welcome again. We are solving some questions of strength of material. The topic is deflection. Question number 1 is a simply supported laterally loaded beam was found to deflect more than a specified value. Which of the following measurement will reduce deflection? Option A, increase in area moment of inertia. Option B, increase the span of the beam. Option C, select different material having least modulus velocity. Option D, the magnitude of load to be increased. So the deflection formula, general formula is given as WLQ by EI into K. For simply explain, the K is 1 by 48. Okay. So with point load at midpoint. Okay. So that is K into W. Oh sorry, 1 by 48 WLQ by EI. Okay. Now we can see that if I is increased, the delta will reduce. So increasing I will reduce delta or deflection will reduce. So answer is option A. Okay, next, a steel beam of breadth 120 mm and height 750 mm is loaded as shown in figure. E is equal to 200 GPa, and this is your beam. This is 120 km per meter, and this is 50 meters. So question number 2 is the beam is subjected to a maximum bending moment of option A 3375 km meter, option B 4750 km meter, option C 6750 km meter, and option D 8750 km meter. Question number 3, the value of maximum deflection of beam is option A 93.75 mm, option B 83.75 mm, option C 73.75 mm, and option D 63.75 mm. Okay, so this is your simple supported beam, and this is 15 meters, this is 120 kilometers, and the maximum bending moment is given by WL square by 8 in case of simply UDL and in case of simple supported beam. So W is your 120 kilometer per meter, and L is 15 meters, so it will be 3375 kilometer meter. So maximum bending moment will be 3375 kilometer meter. Okay. So now the next is we have to find out the maximum deflection. So the formula for maximum deflection in case of UDL is 5 by 384 WL4 by EI. So W is 120 km per meter or 120 Newton per mm. L is 15,000 mm, and E is 200 into 10 power 3 Newton per mm square. I is 120 into 750 cube by 12. Okay. So delta comes out as 5 by 384, 120 into 15,004 divided by 200 into 10 power 3, 4.21 10 power 9. So that is 93.75. Okay. So the answer for this question is option A, 93.75 mm, and this is your 3375 kilometer. Okay. Next, a simply supported beam is subjected to a UDL W kilonewton per meter as shown in figure. The deflection at the midpoint is made 0 by introducing. So this is W, this is R1, this is R2, this is P. Okay. By introducing a probe which gives reaction P. The value of P in terms of W and L is option A P is equal to 3 by 8 WL, option B P is equal to 5 by 8 WL, option C P is equal to 7 by 8 WL, and option D 8 by 5 is equal to P is equal to 8 by 5 WL. So in case of UDL, the deflection is given by 5 by 384 WL by EI. So as here UDL is W, so if we do not consider this, then the deflection is of the midpoint is 5 by 384 WL4 by EI. Now if we consider the deflection of due to point load, okay, due to point load upward, and then the deflection is PLQ by 48. So equating these two, we get the relationship between P and W. So that is P is equal to 3 by 8 WL. Okay, so answer is A. Okay. Next, beam GHI is supported by three pontoons as shown in the figure below. The horizontal cross section area of each pontoon is 8 meters square. The flexure rigidity of beam is 10,000 kilonewton meter square and unit weight of water is 10 kilonewton per meter cube. So this is your beam GHI, okay, and it is supported by 3 pontoon and load the 40 kilonewton reaction. Here there is water and the weight of water is per unit weight of water is 10 kilonewton per meter cube. Okay, the question number 5, when the middle pontoon is removed, the deflection at H will be option A 0.2 meter, option B 0.4 meter, option C 0.6 meter, and option D 0.8 meter. Question number 6, when the middle pontoon is brought back to its original position, as shown in the figure above, reaction H will be option A 8.6 kilonewton and option B 15.7 kilonewton, option C 19.2 kilonewton, and option D 24.2 kilonewton. So when this middle pontoon is moved, then there is only 40 kilonewton load will left, and there is reaction at G and I. So this 40 kilonewton will provide a reaction 24 kilonewton and 24 kilonewton at G and I. Okay. Now as pontoon itself cannot provide reaction, so it provides reaction by immersing the pontoon in water, and buoyant force will act on the pontoon. Okay, so buoyant force will act on pontoon, both the pontoon. Okay, so let H be the immersion of pontoon in water, then the A into H is volume of pontoon that is in water, and this is the weight of water acting per unit weight of water. So from this we can find out A, to find out H. So A is given as at 8 and omega W is given as 10. So we can find out H. H is 0.3 meter. So whole of the assembly will go through, the whole this assembly will go by an amount of 0.3 meter to provide reaction there. Okay. Now the so total immersion of the whole of the beam GHI is 0.3 meter, and there will be extra deflection of midpoint, that is given by PLQ by 48 I, and that will be your 0.1. So the deflection of the midpoint will be 0.3 meter plus 0.1 meter. So total deflection downward will be 0.4 meter. Okay. So that is 0.4 meter. So answer is option B. Now in the second question, the pontoon has been brought back to its original position. Okay, and then we have to find out the reaction or the immersion. Okay, now when the pontoon has been brought back to its original position, suppose it provides reaction R. So deflection of the midpoint will be P minus R L2 by 48 I, and the reaction at G and I is for Q, because the reaction will be equal to RG and RI is equal to Q. And this reaction will again be provided by the immersion of pontoon in water. So that is, suppose X is the immersion of pontoon in water. So X into A into gamma W is your Q. Okay, so X into A is your 8 and gamma W is your 10. Okay, so X will be Q by 80. Okay, so X is immersion of pontoon. Okay, so that is so we know that the 2Q plus R total upward force is reaction on provided by this, reaction provided by this, plus reaction provided by this. Okay, will be your 48. Okay, balancing forces. Okay, and now the middle pontoon goes in the water by an extra amount of delta, that is deflection of the pontoon or the midpoint. So that is, for total immersion of middle pontoon in water is x plus delta. Okay, so the reaction is x plus delta into area into omega W. So that is R. So area is 8. This is 10. So x plus delta is R by 80, and x is your Q by 80. Okay. Now from this we can solving this, and Q is your 48 minus R. And solving this we have delta is equal to 38 R minus 48 by 160, but the deflection is also given by this. Okay, this P minus R, so P is a 48. Okay, so P minus 48 minus R into 10 to by 48 into by EI. Okay.